Well, hello, ladies and gentlemen. Hello, hello, hello. My name is Roger Weitzel. Today is 12/21/2020. I think it's 3 days till Christmas. Sorry about that. That was a phone call. Anyway, you guys are more important than that phone call. So here we go. Today we're going to work with volume a little bit, and this is sort of an applied problem because, well, it could actually happen in real life. And, you know, I get it all the time. When am I ever going to use this? Well, today we're going to do an example of where it could actually be used. So we're going to calculate the volume of water in a swimming pool. And I think that in itself is fun because I love swimming. All right, here we go. I'm going to share my screen. Okay, so first off, I want to, I guess, start with the problem here. So I've got two files here. This is our original problem here. And the problem is Mr. Miller is considering putting in a swimming pool at his backyard. The dimensions are given. Calculate the volume of water required to fill the pool and the cost of the water at $3.39 per 100 cubic feet. So it's important to keep track of these units. Obviously, in one dimension, we have feet. Once we have two dimensions, we have area, which is square feet, and now we're dealing with volume, so it'll be cubic feet. So here's some preliminary work that I did. I started drawing these boxes, and then I decided that Mastercam could do it better. So let's switch over to that. So here is the drawing, and you can see that this gives me the option of kind of looking at it and deciding what I want to do with it. I put the dimensions on here, so we know that the pool is going to be 20 feet by 50 feet from the top view. And then the shallow end here is going to be 14 feet. The deep end is going to be 14 feet. And then we've got this slant right here. So the hardest part of this problem is to calculate this section right here in the middle. So once we decide how we're going to do it, it's not going to be that bad. So I just wanted to show you that when you draw something in Mastercam, you typically want to know what it looks like from each of the three planes. So I have just put this is what you're going to see on any print that you see of a part in a machine shop. So this is your front view. This is what the swimming pool looks from the front. If you were looking down the end of it, it would look like this. And if you looked at it from the top, it would look like this. All right, there's your little teaser on Mastercam. So now let us switch over to what I did to try to get this problem rolling. So I took this cross section here. Now, what we want to bear in mind now is that once we want to go to view and back to the isometric. So this looks nasty, but the fact that we have a nice uniform cross section makes this actually pretty easy if we can figure out how to do the front face here. The other thing I guess I was going to mention is that we also have this little function here that can tell us the area. And what we're going to say is we want so it's telling us that that area is 450 square feet. We know the depth is 20 feet. So we kind of, I originally drew this up so that I could check my work. But since you're my friend, I'm going to just tell you in advance that the front is 450 square feet, and then we can just multiply it by that depth. All right, very nice. This is the cross section then that I have when I look at it from the front. And when I do that, I break it up into 3 much easier figures. So I have a rectangle, I have a triangle, and I have another rectangle. The 22 comes from the fact that I knew the overall length was 50. The depth, I mean, the width of the deep end is 14. The width of the shallow end is 14. That leaves us 22 feet in the middle. So at this point, it just becomes a matter of identifying, okay, we want to work on area number 1 first. So that's a rectangle. That's just going to be the base times the height. That's going to be 10 times 14, which is going to be 140 square feet. Okay, done with the first part. I did area 2 second. So here's area 2. This is another rectangle. It's 50 feet by 4 feet. This is another base times height, 50 times 4, and we get 200 square feet. Now we're going to do area number 3. That's a triangle. The area of a triangle is 1/2 base times height. So here we put in 1/2. Base is 22, height is 10, and that's going to give us 110 square feet. So the total area of the front is going to be area 1 plus 2 plus 3. So we just take 140 plus 200 plus 110, and we come up with 450. Now we want to try to do the volume. The volume is just going to be this front surface area times the depth. So that we calculated the 450 right here. The depth was 20, and we come up with 9,000 cubic feet. Now, when I did this problem, I thought, when you deal with water, rarely are you talking in cubic feet. Almost always they tell you what it is in gallons. So, and besides, that doesn't mean much to me. So I wanted to put this into gallons. So this gives us a little opportunity to talk about our conversion factors. So in order to change gallons, which is a measure of volume, and cubic feet is a measure of volume, I can just use a conversion factor. Now the conversion factor is that, now which one do you think is bigger, a cubic foot or a gallon? Well, as it turns out, there's a cubic foot is much larger than a gallon because we have 1 cubic foot. Ooh, 1 cubic foot is equal to 7.48 gallons. So this is an equality. Becomes a conversion factor. That means that I can use this relationship to change from cubic feet to gallons. So I'm taking 9,000 cubic feet. I take my conversion factor. I have 7.48 gallons for every cubic foot. Now, as we talked about before, when you set up a conversion factor, what you want, these are equal. So you can have either one on top. I want to make sure that the cubic feet cancel out. So the cubic feet need to go on the bottom. These will cancel. So now I'll have 9,000 times 7.48 gallons. And that's how many gallons of water that I have. That sounds a lot more impressive. I would rather say 67,000 gallons. I'd rather say that than 9,000 cubic feet. All right, we touched on a few things here. I want to remind you that, you know, when you say, hey, when am I ever going to use this? There's plenty of jobs for CAD designers, CNC programmers. There's a lot of positions related to drawing up a 3D figure. And, you know, if it interests you, you might as well snag one of those. All right, that's it for today. Talk to you later, and live with passion.